Okay, let's take out this second part of our geometry section 2.6, and we're going to pick up with example 2. So here we are. We're going to write another algebraic proof, and this time we're going to write one for this particular situation. So if the formula to convert a Fahrenheit temperature to Celsius temperature is Celsius equals 5/9, the quantity of Fahrenheit minus 32, I don't know where that came from, then the formula to convert Celsius temperature to Fahrenheit is going to be this one. F is equal to 9/5 C plus 32. Write a 2-column proof to verify the conjecture. All right, so here's our 2-column proof. We start off with the hypothesis, if this, then that, right? And we're going to prove the conclusion by going through a process of seeing how we're going to, in a sense, transform this equation into this other one. So the first thing we start off with is our given statement, and our given statement is this statement here. So I've rewritten the given information, and the reason why we can say that this is true is because it was given. So my first statement is here and my first given statement is here. And remember, my goal is to do this. You have seen this done before. You know what this is. This is solving literal equations. Remember back in algebra where you manipulate an equation to make it say something else, or you manipulate a formula to solve for a different variable? That's all we're doing here. So the question is, how do we go from this equation to this one, or this formula to this one? And so what we're going to do is first start to isolate the f variable. To do that, I need to undo what's happening out here. I'm going to do that. I wish I could get rid of the 5/9, and I can. If I multiply both sides of this equation by, let's say, 9/5, right? When I do that, I recognize that bringing this multiplication into the mix, this multiplying both sides of the equation by 9/5, I'm going to cancel this out, and I'm one step closer to isolating that f value. So what I'm going to do is I need to justify the reason. Why can I walk up to this problem, see two things that are equal, and then multiply both things by the same thing and still say that it's equal? I can say that by the multiplication property of equality. All right, so that's just the multiplication, the property of equality handling its business. The next step that I'm going to have to do is a little bit of substitution, which is going to give me the opportunity to simplify what I have here. So I've got 9/5c is equal to whoosh, 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 whoosh. That all cancels out. Sometimes in my mind I have sound effects for different mathematical operations that are going on. Don't judge me. So I get that, and I can say that this is equal to this. These two things are the same by substitution. So the next thing I'm going to need to do is, again, I'm still trying to isolate f, so I've got to get rid of this thing here. I got to get rid of the 32. Had to make this a little smaller so I could have more space, but to get rid of this 32, I think what I'm going to do is add 32 to both sides. This negative 32 is going to get gone if I can add 32 to both sides. So what I do to one side, you know how we do it in mathematics, we got to do to the other. And what gives me the power to do that? I know you guessed it, it's the addition property of equality. And so you can see here, I'm going to highlight what I did. I just added 32 to both sides, and I'm able to do that by the addition property of equality. Step 5 is going to have me breaking this thing down. So 9/5 c plus 32, these guys have canceled out, is equal to f. I am almost there. I can say that this is true because of substitution. I'm substituting one equivalent statement for another. And the final step, and this is going to be a little bit nitpicky, I wanted f to be on this side. F is equal to all of this stuff over here, not this stuff over here is equal to f. So to get it exactly right, I'm going to just start my column, my statement column over here. I'm going to write that f is indeed equivalent to 9/5 c plus 32. And the reason why, I don't know if you remember, is, I feel like scrolling up and showing you. If A's equal to B, then B's equal to A. This gives me the opportunity to switch them around. And so when I come back to my problem, I'm able to say this is true because of, do you remember what it was? Symmetry. Symmetry property or symmetric property of equality. I don't remember if it was symmetry or symmetric, but you get my drift. Does that make sense? I hope so. I hope so. So here we can talk about those same three properties that were in the center of our properties, algebraic properties before. We can talk about them in reference to geometric things. So we could talk about them in reference to segments. Here is a little bit of reflexiveness or reflection. Get it? Okay. Still not a thing. Here's a bit of our reflexive property with segments. AB is equal to AB. Remember, this refers to a length of a segment. Over here, M with the little angle 1, this is the measure of angle 1 is equal to the measure of angle 1. I know it's not earth-shattering, but it does come to play from time to time. Over here, if AB is equal to CD, then clearly CD is equal to AB. That's with segments, and then we can do the same thing with angles, as you can see. Transitivity works exactly the same way. If this thing is equal to that thing, and that thing is equal to the other thing, then this thing has got to be equal to the other thing. Yeah? Yeah. All right. So we see that all of these properties can also be applied to geometric things. And so now this number 3, we're going to write a geometric proof. And one of the key things to do when you are working on geometric proofs, and this is something that I will probably repeat all year, the key thing you're going to do is make sure you know what you're answering. Make sure you understand the question. Right now, this looks like a lot of mathematical gobbledygook, and so you want to make sure and understand before you even attempt starting writing your proof. And oftentimes, students will start writing hoping that something good is going to happen. Don't do that. Make sure you understand what's going on. So let's start there. We are given that angle FGJ, and I'm going to highlight it as I talk about it. Sometimes that's helpful. Angle FGJ is equal to angle JGK. These guys are equal. And oftentimes when we do equal, we use like a little hatch mark. So I might do, well, that doesn't look very pleasing. You might put this mark here and this mark here to represent equivalence in angle. So this angle measure is congruent to this angle measure. And we can talk about congruence meaning equality. And then we see that, let me use a different color, that JGK, that's this angle right here, is also equal to KGH, this angle. Okay, that's good to know. Then they said if this is the case, then x is equal to 6. Well, you remember last time, if is the hypothesis, the conclusion is as after the word then, x is equal to 6. We need to prove the then, and that's what's happening here. So we're given this information, right? This information is the same thing here, and we're going to write a proof about it. So let's do that. So I'm hoping that you see what we need to do. I need to solve for x, obviously, and I need to figure out if x is equal to 6. The only way I can solve for x is if I can take these values over here. Let me make this a little bit larger. If I can take these values and somehow equate them. Hopefully you saw through my discussion and marking of this figure that this figure and this figure is equal. This figure and this figure is equal. So somewhere in my proof, I want to be able to say that these two bad boys are equal. As soon as I write that they're equal to each other, I can rock my algebraic proof skills that I've been doing in the last 2 examples, and then I can get my answer. So that's my general idea. Before I start my geometric proof, I want to have a general idea of where I'm going, and I think that gave it to me. So I got that these equalities that are given will lead eventually to this angle here being equivalent to this one. As soon as I say that, I can set them equal to each other. Boom, bada bing, bada bum, I'm going to get my answer. So let's go ahead and set it up. So my first statement, oftentimes in proofs, your first statement is really going to be the given. So let's do that. So what I want you to see is that I wrote the first part of this given statement. I want to start off with the fact that these guys are, remember the symbol means congruent. These are congruent lengths. So this is congruent to this, and this is congruent to this, and that's given. I didn't write the whole thing. I'm going to save this part for a little bit later. And so now that I've got that given, now I want to talk about something else. I want to talk about not just the congruency, I want to talk about the measures. That's a little bit different. Congruent means that the shapes are exactly the same. Measure means that the measurements are the same. All right, and so that's going to be a little important for me to do. So now I want to just say that I'm going to emphasize the fact that the measure of these angles are also congruent, are also equal as well. So the measure of FGJ is equal to the measure of JGK, and the measure of JGK is equal to the measure of KGH. And that is given by, now this might be a long time ago, it's the definition of congruence, of being congruent. The definition of congruent is having the same measure. So the definition of congruent angles is what I'm talking about. Check out my little cool abbreviations. It might come in handy later on for you. So then number 3, now that I have that, now I want to say the thing that I wanted to say the most, that this angle here is equal to this angle. I don't have symmetry, I don't have transitivity of congruence, but I do have transitivity of equality. That's why I needed to change these to equal signs. So the transitive property of equality says, if you remember, if A equals B and B equals C, then A equals C. That's a lot like what I'm about to do here. I want to say, if this angle is equal to that, and that is equal to this other angle, then these guys are equal. And I can say that now. The measure of angle FGJ is equal to the measure of angle KGH. And I can say that that is a fact by the transitive property of equality. All right, good. Things are going well. So now I'm pretty much where I want to be. Now I'm going to give that other piece of the information, because look, I now have the measure of this angle is equal to something. The measure of this angle is this other angle is equal to something. I think you might know what I'm about to do. First, let me just put this down. So now I'm going to put down this other bit of information about that I have from my given about the measures of these two angles that are important to me. Okay, so I put that down, and the reasoning behind it is simple. It was given. And I like placing it here because now I kind of have a gotcha moment. Now, now I can say that 6x plus 7 is equal to 8x minus 5. How can I say that? Well, let's look at these two statements here. If this thing is equal to this thing, and then I have this thing over here equaling one thing, and then this thing over here equaling another, what did I just do to get to this point? I hope you see that what I did was a bit of substitution. Substitution property of equalities. I'm going to just write substitution for short. All right, so that's the substitution property of equality, and now I got it where I want it. I want to now solve for x. So now I'm going to rock out like this is an algebraic proof, and this is going to be really straightforward from here on out. The first thing I might want to do is to, I don't know, get the x terms on this side. So I might subtract 6x on both sides of the equation, right? Subtracting 6x on both sides of the equation. Let's highlight that 6x so you can see what was brought into the problem. And now that I've done that, hold on, now that I've done that, I can see that this number 6 step was the subtraction property of equality. All right, and then the 7th step is going to be to simplify. When I join these guys together, it's gone. So I'm left with 7 is equal to, join these guys together, 2x minus 5. And now I know that the reasoning behind that is substitution. After that, I'm going to move on and do the thing that I would do. I would now get rid of this 5 by perhaps, let me use a different color here, adding 5 to both sides, right? So my problem is going to be 7 is equal to 2x minus 5, but on both sides of the equation, I'm going to add 5. And when I do that, when I can add the same thing to both sides, that's because of the addition property of equality. Now, by substitution, I'm going to join these guys together and these over here to get that 12 is equal to 2x. And I think you know that to solve an equation in this state, I'm going to have to divide both sides by the same number. So that's the division property of equality. And then finally bring it home by substitution. I get that 6 is equal to x. And then So after 6 being equal to x by substitution, x is equal to 6 by the symmetric property of equality. I hope that made sense, okay? So look, I'm going to stop here. I am looking forward to hearing your questions. Let's talk soon.